The longer title for this presentation, what I worked with, was Risk Assessments, Safety Principles in Accordance with United States Law and the Production-Related Risk Assessments according to US and international standards. I see that this is a little bit different than what was, what's actually printed in the little brochure here. That's what I worked with. This was the longer description also. It's a discussion of risk assessment as a basis for safety standards in contrast to basing standards on detailed checklists of what must be done or achieved. The presenter, me, I will argue that making a safe environment should be seen as creative work, not drudgery, and risk assessment is a tool that helps in achieving that. There are really, as we discussed what I was going to talk about via email, I have only met the people here for the first time this morning, face to face. This is what we decided it would be about, and there are really three parts to this topic. One, risk assessment in US law. I hope that will interest you. Two, risk assessment in US and international standards. Three, risk assessment and creativity and safety. The last point is what I really want to talk about. This conversation comes from a discussion I had with Jürgen Kreis in the VPLT stand last year, in which we were talking about trying to make safety be something creative rather than something that, okay, we're going to have this wonderful event and it's going to be great and it's going to be beautiful and it's going to be exciting. Oh, I also have to make it safe. Oh, I also have to work with the police or the fire department or all these other people who are going to tell me that I can't do things. Ugh, this is drudgery. I would like to say that's just as much part of the creative work as imagining this fancy event. Just as you have to work with prima donnas, artists, who will have special demands, and part of your job, if you're successful, is to meet those special demands and learn how to talk to them. Working out these safety requirements also is part of that whole job. Okay, first of all, let me go back to the first part of the thing, though. Risk assessment in US law. The United States of America is not united, okay? This is something that I wind up explaining to people. I will receive emails, most often from German manufacturers of stage equipment, who will then ask me, well, what are the regulations? Say they'll have something like this portable platform system here, and they'll ask me, what are the regulations I need to meet? And I will just sort of laugh if we're having a phone conversation, or chuckle to myself if this is by email, and tell them that we have 50 states, the District of Columbia, then we have 12 territories, all right? Some of those territories, they're parts of the United States, but nobody lives there. For example, Palmyra Atoll, there are various people that go there to do research in the middle of the Pacific Ocean, but nobody lives there all the time, okay? And then, but within these sort of larger political areas, we have counties, and we have cities, and we have towns. Now, when you start dealing with something like this, some kind of a portable stage that you've put in, nobody at the federal level is going to be looking at it. It probably is going to be somebody at the local level. And at that point, if you do the multiplication of this, there are thousands of different local jurisdictions that might be involved. Most of the time with something like this, nobody cares. But somebody might be trying to use your product in a place where the local building authority, the inspector, does care. And it varies all over the place as to how much they're going to worry about it. My advice to German manufacturers in general is, if you conform to whatever standards you have in Germany, it will be fine in the United States. All right, it will meet whatever requirements are there. You are not going to persuade the local authority having jurisdiction, is the term that we use to describe whoever this person is who can tell you if you can do this or not. If you say, well, it meets a DIN standard, he's not going to care. But if you say that the loading is such and such, is designed for this loading, oh, okay, fine, and it's going to be okay. Standards are not law in the United States. They're voluntary unless there's a political subdivision that writes them into the law, or they are cited in case law, okay? There are a number of standards that are written specifically for the purpose of turning them into local regulations. The National Fire Protection Association writes some of these standards. People will talk about the Life Safety Code. That's NFPA 101. Or they will talk about the National Electrical Code. That is NFPA 70. These are both American national standards, but they're just simply voluntary standards. They're model codes. When people talk about the National Electrical Code, well, it was written by the organization as a model for the entire United States, dealing with the wiring practices, the work practices, the voltages, the frequencies, et cetera, of electrical power in the United States. But it has no weight as law unless a local jurisdiction adopts it as law. I work in New York City. Their electrical code there is very much like the NFPA's National Electrical Code, but the code from about 6 years ago. Because these standards are rewritten about every 3 years, and then eventually the local jurisdictions get around to adopting the latest version, either saying you will follow that, or by taking the wording directly out of it and putting it into local regulations. But they're a little bit slow. There are still some places that will talk about fire safety curtains. These are the curtains that come down in front of a stage to stop any kind of smoke or flame, which we assume is going to be on the stage, from getting into the audience. They will talk about it being made of asbestos. Nobody now is going to make a fire safety curtain out of asbestos because of the carcinogenic hazard. But nevertheless, some of these regulations cite old versions of the standard, and so that's what they do. Case law is something that makes something essentially have legal weight. It's not a very good way to do it. Essentially, if somebody is injured and there winds up being a lawsuit to establish who was at fault, who caused this injury, and who therefore should pay damages, very frequently standards will be cited in those things. Usually American national standards will be the ones that are cited. Not necessarily always. Essentially what they're going to be looking for is what would somebody who is competent, who is skilled in the art, who knows this technology, what was the consensus in the industry of how you should do things. Standards are, by definition, they are consensus documents. What makes an American national standard special, by the way, besides its extra weight, if you start arguing with an AHJ, an authority having jurisdiction, a building code official, or a fire marshal or somebody, an American national standard has greater status than, say, a standard which is not. But really all the American national standard designation means is that the standard was developed in a way that allowed input from all the people who are affected by the standard. So that would be, for example, if we have a standard, and we do have a standard for aluminum trusses. Okay, the people who wrote that standard are people who design the trusses, people who make the trusses, people who sell the trusses, people who use the trusses, people who stand under the trusses. Okay, and we have to have a procedure where everybody has their little bit to say about it. And we also, PLASA is accredited, right, American national standards. We're also audited to make sure that we actually follow these procedures. So an American national standard is not something that is cooked up in a back room. Maybe the first idea for it is cooked up in a back room, but then it has to be developed out in the public so that it is a reasonable representation of what the informed opinion industry thinks. Right? Standards basically have two different functions. One is they give advice to people to help them avoid problems, enhance safety, etc. After I wrote this, I also thought to facilitate trade. If we all agree exactly on the shape of a nut that has to go onto a bolt, and that's described in a standard, and it is described in a standard. Now this makes it easy. If I make nuts that conform to the standard, somebody else can buy them, and they will know that they will work on bolts that are also made to conform to the standard. It helps trade. There are standards for how you measure how much area is in a commercial building, since most of the time rents in commercial buildings are done on the basis of how much per square foot. There's a standard for how you do that. Because we've agreed on a standard, now we're not arguing about, well, how are you measuring this? No, it's understood, so it helps trade. This first part is the part that I find most useful too, or at least the part that I like. I come from a family of school teachers. They're always trying to educate people. That first thing there is really education. Now the second one is one that people frequently think of when they think of standards. That is to help enforcement officials determine if what someone else has done meets standards. When I go to a party and somebody says, well, what do you do? I say, I'm the technical standards manager for PLASA, and I immediately start talking about standards. They say, oh, you're the person who makes sure that people do blah, 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 whatever it is. Somehow or other, it's a police job. This is an important part, but it's not all of it. Standards that are written into US law usually are minimum standards, and they're for that second part. They're for easy enforcement. Okay, they almost never require a risk assessment because that's not easily evaluated by an inspector. They're usually for stationary things such as buildings and electrical systems in buildings. Okay, that is where we have the most enforcement. That is, if you're building a building, or you're doing wiring, or you're changing a building, when you're doing a special event, depending on where you are, there might be a lot of regulations. Other places, it's very, very lax. Some of the other people were talking about having to get permissions to be able to do an outdoor event. In some places in the United States, that permission essentially means that you've registered, I'm going to be doing this event, okay? I pay a fee, we're done. Other places, this would mean a whole list of permissions and working with various safety officials, civil authorities. It depends on where you are. It's all over the place as to what those regulations are. But most of the time, anyway, the things that are written into law are very clear. They're very black and white. Later on, I will get to a little bit of a passage from the Life Safety Code and FPA 101 that talks about how much light you need lighting a path to an exit, to an emergency exit. Okay. They usually don't require a risk assessment, because with a risk assessment, essentially what it allows a person to do is to say, I'm planning an event. Sit down with a team that's involved in planning this event and start looking at what are the things that are possible hazards, how likely are these bad things are to happen, what would be the consequences if these things happen, and then do sort of a ranking of them to decide, well, what is either, it would be catastrophic if it happened, but it's highly unlikely. What would we do if a satellite fell out of orbit and came down into this mesa right now? Okay, it would be catastrophic. It's not very likely. Okay, or the things that are likely to happen, but it's just not going to hurt anybody. So you rank them. And you deal with the things that are both very likely to happen and also are going to have bad consequences if they do happen. And you attack those first, and you figure out ways, there are lots of ways to do things, to either make them less likely to happen, or to make it so if they do happen, very few people get hurt, or there's very little property damage. And you work on this in sort of a reiterative fashion until you get down to a point where you say, oh, this looks good. Now you have a plan. Now you implement the plan. And then if you're really doing this properly, you not only then, after the event is over, or through the event, you monitor things, and from what you learn, you then can modify the plan for the next time that you do something like this. All right, it's a reiterative process in which you work over and over again. But the key is that it allows you to make your own decisions as to what's really a problem, how likely is this a big problem or a small problem, and how you're going to address it. That's very difficult then for somebody who is not part of your organization, who has no experience, or as the first person was talking, has no qualifications, to come in and look at your risk assessment plan and say, yes, it is good, or no, it is no good. Instead, they're more interested in things like, for something on an exit path, the standard says it shall be no less than 11 lux. Fine, it's 12 lux. Very good. Never mind that actually you're expecting a lot of traffic on that path, or the people who are taking that path are perhaps aged and can't see very well, and 11 lux is maybe not enough for them. It doesn't matter. It's more than 11 lux, we're good. Then there are also standards that you might say are legally implied. Product safety standards and testing to these standards is one of them. In the United States, we have a strong tradition of third-party assessment. Our Occupational Safety and Health Administration says that if an employer is having employees use electrical equipment, that electrical equipment has to be acceptable. And you go through a long list of things in the OSHA regulations to discover what acceptable means. And there are essentially 3 different ways that things can be acceptable. One is that, say I'm a manufacturer and I'm making something for you. I design the product, I make sure it's safe, I do tests to ensure that it's safe, I give you the documentation that says that it's safe, okay? That works for that one transaction. You cannot sell that to somebody else though. That's just a custom-made product for you, which is our what do I want to say? That's our free pass, if you will, for custom-made electrical things for shows. The second one is if a local authority having jurisdiction says it's okay. The fire marshal comes in, he looks at it and says, oh, that looks lovely to me. Okay, it's all right. The third way, though, is the way that OSHA expects things to be done most of the time, which is that it is tested and certified as safe by being listed. The language is very strange, even in English. Being listed, okay, by a nationally recognized testing lab. There are several organizations, they're private testing laboratories that will test products, and they will essentially say they are safe. Or if they're not safe, they'll tell you that you have to rework them until they are safe. Those testing labs will use standards for that testing. So the law itself doesn't say it has to meet this standard. The law says it has to be tested by a lab, and the lab has to find it safe. That lab is then going to use the standard. And there are a variety of standards that they can use. Underwriters Laboratory is the best known testing lab in the United States. It is not the only one. It's probably the oldest, though. It's over 100 years old. They have written a lot of standards for the American market. Underwriters Laboratory now, though, is a global testing service. And the people that they test for are global companies. They are making products for many markets. They will very frequently, in designing the product, use an ISO or an I-ESC standard. So now we have a lot of parallel UL standards. We have the one that they wrote in-house, is really about American practice. And then they have also adopted an ISO or an I-ESC standard, with or without some modifications, okay, as a UL standard, which is an American national standard. All right, so this is I've got a raised eyebrow here, but this is the way that it works. And when you take a product to UL, you can then discuss, well, how should this be tested to make sure that it's safe? We can use the American standard, which makes no sense in Germany, okay? Or we can use the I-ESC standard, which is acceptable in the United States, and also it's acceptable in Germany. Which one shall we use? Okay? But at that point, when you start talking to the local building official, that person is going to want to know, was this tested to an American national standard? Well, yes, it was. It happens to be identical to the I-ESC standard, but all right, it was tested to an American national standard. Good. Okay, and then we also wind up with risk assessment to provide a legally mandated safe workplace. Now this is a little bit slippery, okay? I've got a sort of a horrific story, though. At least it was something that caught my eye. Last year, on the 20th of May, 2012, Nancy Harris was a 76-year-old clerk. This is a woman working way past normal working age, was working alone in a Fina whip-in store. This is a convenience store that's sort of attached to a petrol station. It was early Sunday morning. She's working there alone. A man came in carrying a glass bottle of some flammable liquid, robbed her, took all the money out of the cash register, poured the liquid all over her, set her on fire. She was horribly burned. She died 5 days later as a result of her burns. Okay, it's a horrific story. OSHA, the federal OSHA, came in afterwards. Okay, you have an employee who has been killed on the job. Whenever you kill people on the job, suddenly you have inspectors. Generally in the United States, you don't have inspectors until you kill somebody. The thing that you need to do in general is don't kill people, okay? It really complicates things. All right, so we have a woman who was killed on the job, so the OSHA inspectors, Occupational Safety and Health Administration inspectors, showed up, looked at the store and how it was arranged, went and looked at the other 3 FINA whip-in stores in this Texas, Dallas-Fort Worth area, found that they were all the same, and cited the employer for failure to do a risk assessment to evaluate what were the risks to the clerks working there, their employees, and then take steps to mediate those risks. Indeed, any work at a convenience store, at least in the United States, having only one person on the job makes it so that person is vulnerable to people who would come in to try to rob them. Okay, so usually convenience stores will either have 2 or more people on the job, or there will be a physical barrier between the clerk and customers. It's very intimidating, but if you go into a lot of these stores that are attached to petrol stations in the United States, the person who is taking your money is essentially in a plexiglass, an acrylic box with acrylic that's about that thick so that it's bulletproof. Okay, and you're handing the money through a little door. I mean, they don't have security like that in banks now, most of the time. But in banks, you never have one bank teller. You always have many, okay? But in these stores, very frequently, they only have one person. So that's the way of providing safety. But anyway, there are no regulations that say that this is what you have to do, that you have to anticipate that somebody is going to come in, and after robbing somebody who was 76 years old, the young man who did it was half this person's age, just walking out with the money, but set her on fire. There are no detailed things that say exactly what you're supposed to do, but what is required is a safe workplace. How can you get to a safe workplace? Well, doing a risk assessment and then taking steps to control those risks is one way of doing it. Okay, in general, few US standards that are written for enforcement use risk assessment, as I said, because it's difficult for an inspector to just walk in and say, well, where's your risk assessment? Apparently at the PLASA trade show in London, they will come in and they ask, what's your risk assessment for setting up the stand? But most places in the United States, that just simply will not happen. Risk assessment techniques are often specified in ISO and European standards. Some US standards, particularly for machinery, require or recommend risk assessment, and we are incorporating risk assessment in some of our standards. But I have to say it's still controversial. We have our standard for overhead winches, not chain hoists, but wire rope winches, uses risk assessment, and that's ANSI E1.6-1. It requires you to do that because they started looking at, these are the winches that go into theaters generally as permanent installations, and trying to come up with sort of minimum standards. This is exactly what you have to do. They worked on that for a while and then realized that this was absurd. It really depends on what the risk is. I have taught stagecraft, and I've worked with some people who said, for example, that you never use unrated chain or anything when you're suspending a load. Okay, because of course if it's unrated, if you use, say, twine, you don't know at what point it will break. This is very good. I taught, you go ahead and use unrated stuff as long as if whatever it is that you're holding up, it doesn't matter if it falls. If, for example, I have a banner that's, say, 1 meter by 1 meter, made out of muslin, and it breaks loose and falls down not in any path that somebody needs to walk on, well, this is embarrassing, but there's no harm. So what difference does it make if I use string, something very lightweight, to hold it up? It would be absurd at that point to use load-rated chain to hold up this particular thing. Where was I going with this? But anyway, E1.6-1, they decided they should use risk assessment. And the leader of the person who was actually part of the task group writing that made a big deal about how this was new, this was exciting, this was the way to go. He was at a meeting 3 weeks ago, in which he was urging one of our other standards to be changed into one of these conformity standards where you have minimum things and it's easy to test to. And he felt that was the way that we should go. It winds up being something that we go back and forth with. Okay, here's an example of a US enforcement standard. I've already talked about this one. But this is NFPA 101. Clause 7.8.1.3, which is about egress lighting. And it says the minimum illumination for floors and walking surfaces, other than new stairs, shall be to values of at least 10.8 lux, 1 foot candle, measured at the floor. In assembly occupancies, which is a place like this, or a church, or a theater, okay, the illumination of the floors of exit access shall be at least 2.2 lux, which is 0.2 of a foot candle, during periods of performances or projections involving directed light. Okay, these are the absolute minimums, and they're very good it's easy to test to. But as I had said earlier, is this really appropriate? If you have something where, for example, you could expect some people to get up and be moving up and down the aisles during the presentation, you should probably have higher levels. If you have an audience that has difficulty seeing, then you probably should have higher levels, okay? And I would argue that this is important, not just for safety. I mean, we don't want these people to fall, but also for the show. If you have somebody get up in the middle of the show because he absolutely has to go to the toilet, and he falls in the aisle, it stops the show. I mean, you might still have the performance going on up here, but you're going to wind up with people trying to help this person up. It's going to be a big distraction. So it's not just simply a safety issue, but it's also a quality of the event issue. This particular standard also, see, it says at the beginning of it, this is a book, by the way, that's about that thick, that it is not a design guide. But nevertheless, because there's no mention in it about risk assessment or about any kind of discussion of what might be better, a lot of people will look at this and just simply say, that's it. That's all that I have to do. I'm done. Okay, going back to the entertainment standards, these things are well established in European and international standards and in SEN workshop agreements. DIN 56950, which we heard about in the last section, okay? Here we have a very nice, this is a classic flow diagram of how you do a risk assessment. All right, CWA, or are my notes here, CWA 15902-1, which is the SEN workshop agreement, which was made by sort of taking British standards and German standards and Swedish standards and smacking them all together and coming up with something that was a good compromise, also has risk assessment in it. And if you look at those pages in that document, it looks just like something out of the previous version of DIN 56950, because I'm sure it was taken from that, except that, of course, the copy I have of the CWA document is in English. Okay, I've already talked about this a little bit. This is still relatively new and controversial. It does solve the problem of not restricting creativity, but concerns remain about proving compliance. There is a tension there. I work for PLASA. PLASA is primarily a trade association. What PLASA is now is made out of the merger of PLASA in the UK and ESTA, the Entertainment Services and Technology Association, the trade association in the United States. ESTA started their technical standards program quite some time ago because they felt that for the members of the trade association, we needed to have a program to write standards for our industry, standards that were not being written by other organizations for the benefit of the members. So we wind up anyway we try to write standards that are sort of performance-based, that would describe what is the effect, what we're trying to achieve without telling people exactly how to get there. Because another part of our trade association is the manufacturers and people who are creative, and we don't want to make it so that, well, let's talk about a manual counterweight rigging system, for example. We want to be able to have safe counterweight rigging systems, because if they're not safe and people are hurt, this has well, it's very bad for business. We're going to wind up with all those thousands of local jurisdictions writing their own rules for how rigging systems in theaters should work. But we don't want to restrict creativity because we also don't want to sort of specify this is a system, at which point everybody has to make the same system, and the only way they can compete is on price. We want to have innovation. So we want to describe what it has to achieve to be safe, but allow different ways of getting there. But at the same time, we have the problem that we will have local authorities having jurisdiction, AHJs, building inspectors, who might have very few qualifications and even less competence, coming in and wanting to see if it's okay. And it's much easier to give them a rule book. Sometimes we have sort of a parallel track. That is, we will actually wind up with a standard that generally describes what needs to be achieved, and then it will have another section in it, sort of an annex that says, and if you build a system like this, and that describes how people usually do it, it will meet the objectives of the first one. So you can either do the cookbook at the end, or you can do something innovative. That's what we try to do. Sometimes it works, sometimes it doesn't. Okay? This is a little bit from my own experience. This is how, excuse me, risk assessment can be creative. Some of you who have heard my other presentations on this will have recognized this picture. I do some theater work. I do some special effects work. I don't do very much. My salary really comes from working for PLASA, but this is a show that I worked on, Hair, which was done several years ago. And the director wanted to have some kind of a live flame, sort of as a memorial flame for Claude Hooper Bukowski. Usually people think of Hair as being this musical in which all these hippies dance around and sing and stuff. Yes, it is that. But it's also a story about a young man who is drafted, decides to go to war. He is shipped off to Vietnam. He dies in Vietnam, and his friends mourn him. This is being done at a college in Connecticut. Connecticut has some fairly stringent fire rules. Where's my little... Hang on here, I've just lost my place. Oh yeah, okay. Back in 1944, there was a circus tent fire in Hartford, which is the capital of Connecticut. And it killed about 168 people and injured about another 700. Now there's nobody working now in any fire department that was working in that fire department back in 1944. But this is part of the culture, okay? Connecticut is very strict about fire laws on stage, and NFPA 101, the Life Safety Code, which is a model code, essentially says you cannot have open flame on stage unless it is acceptable to the authority having jurisdiction. So I needed to have essentially permission from the authority having jurisdiction to have this. As it worked out, I had to get permission from the Fairfield Town Fire Marshal and also the university, the campus fire marshal. Well, there's a standard for flame effects, okay? NFPA 160, which is an American national standard. It was written, however, when in Las Vegas they started putting in flame effects as permanent attractions. For example, the volcanoes outside the Mirage Hotel. And I have a copy of that. I happen to be on the committee that is responsible for that particular standard, but that's what it's written for. It is written for code enforcement officials to deal with gas-fired flame effects. This had nothing to do with that. So the standard was completely useless. I just had to do essentially a risk assessment. I sat down and sort of did a list of everything that I thought could go wrong and everything I thought that the fire marshals could think could go wrong. Okay? I didn't want them to come up with a, well, what about, and have me go, well, I don't know, I hadn't thought about that. All right? And essentially made it so that at least two things, it wasn't supposed to go wrong, and if it did go wrong, there were at least two things there to contain the fire or to make it so that somebody wouldn't get burned. I did the demonstration for them, and one fire marshal said to the other one, well, what do you think? And the second one said, I think you should patent it. Okay, which was great. Then I knew that we had it all done. But what I did for this was I I wound up with a very detailed, besides this gadget, which I won't tell you all about, except that it had a micro switch on the bottom so that if you bumped it a little bit, bang, there was a lid that went across the fire, snuffed it. And also that big guy there, he was somebody that had recently come to the university, originally to be on the football team. You know, American football, this is where they don't just kick a ball around and stuff, they grab each other and throw each other to the ground. He was there as the trained person responsible for the fire, and also, highly unlikely, but I have seen it twice in my life, where somebody in the audience decides that they need to be on stage. And we could talk about the actors being trained not to get too close to the fire, but anybody who was crazy enough to decide that he wants to join the show might be a problem. That's why that guy was there. He was there to make sure that person didn't get it all close to the flames, okay? And it worked. I have to say, I got permission, I went through all the proper channels here, and it worked very well. Okay. Oh, that's the stuff I've just already said. Okay. And it worked. Okay. This is back to where we started. This is the VPLC stand last year. And Jürgen Kreis we were talking about this. This was a water arch. So they had these water jets that were making these continuous streams across the opening. And then, of course, that water had to be recycled. So there were pipes that came across here. And this is a concrete floor with tile on it. So how do you do that? Well, you're going to have some kind of a hump there. And we were talking about this and thinking, this is actually pretty good. All right, they've got this nice little cover that goes over it. All right, but it's still a difference in level. Could be something somebody could trip over. So it's a different color carpet than the rest. Okay, so if you're coming up to this, you have something that helps get you over the water hoses so that you don't trip, but also in an unobtrusive, fairly good-looking way, it also signals to you that you're going to have to pay attention to this. It doesn't match the tile, it doesn't match the carpet on the other side. We thought this was really good, a very creative way of addressing the problem. All right, this is at the USITT conference 3 weeks ago in Milwaukee. There was a cable, electrical cable, run underneath the carpet. And so what was their solution? To put 3 orange cones on it. Now, in my experience, orange cones usually mean don't go there, okay? You put a lot of them to block off a road, or if you're trying to save a parking space, you put a lot of them in the parking space, okay? Or if there's a loading dock you want to keep clear, you put a bunch of cones there. What does it mean here? Does it mean don't walk down the aisle? It's just completely ambiguous. Now, I did not hear anybody go, oh, boom. So I guess nobody tripped. So it must have worked. But I thought this was an amazingly inelegant and stupid way to handle the problem. Okay, my conclusions, with a little bit of time for questions. Risk assessment is a valuable tool for safety and for better events. Really, safe events are better events. When you have people getting injured or hurt or killed at an event, it ruins the show. Okay? Bottom line, never mind, we can set aside all the moral things about we shouldn't hurt people. Let's just simply accept that. But just from a business basis, when you hurt people, it's fabulously expensive. You don't save anything by doing that. Risk assessment can be creative, satisfying work. It's well established in European and international standards. It's not well established in US standards, but it is used, and its use is growing. That's it. That's my presentation. Yeah. I didn't put up a questions thing here, but I understand that that's what will happen. Mein Deutsch ist schlecht, so I hope somebody translates for me.
Thank you, Mr. Röding, for this wonderful presentation. Are there any questions? Haben wir ein paar Fragen dazu? Ja, wunderbar.
Hello. I'm a stand builder in Germany, and we build 2,000 projects per year, and therefore we feel sometimes risk assessment is more paperwork than any helpful. Because for example, 30 by 30 feet booth, you have to done these risk assessment. Even the European like all to do it better than ever. So for every stand, you have to do these risk assessment, method statement, health and safety requirements, and all the other stuff. And you have to name all the names who work on the place, and even that 4 or 7 weeks in advance.
Yeah.
Normally, even the customer don't know that they go to this show 4 weeks ago, before the show. And therefore, we feel at the end, there's only paperwork, more and more. And even, for example, you make a show like this here in Frankfurt.
Yeah.
There are 3,000 exhibitors. You get risk assessment, I think, more than 10,000 sheets of paper. Who will read, who will help this, and how we can do it easier, make it more standardized. And sometimes it's easier to do this in a creative way, like you have told us. We will do this all the time because we don't accept even all the formulas you get from the shows.
Yeah.
And we feel we work only for the insurance and for nothing more, and for someone who is responsible if there's an accident.
Yeah. Well, I'm sorry that it feels that way. My experience with it has been, though, I mean, yes, it's lots and lots of paper, but then again, this is where word processors are wonderful. If you're doing the same thing over and over again, you can use pretty much the same document. But where it's useful, besides making the insurance companies happy, is that when I've worked on a load-in and there isn't a method plan, and we're making it up on the job, it usually winds up being very stressful, and it takes a lot of time. And people are more likely to get injured then. When I work on a show where there actually is a plan for how we're going to do things, it always goes, at least in my experience, more quickly, with less labor and fewer problems. Sometimes the plan isn't right. You get there and you discover that I was told that this ballroom was 30 meters long. It's 40 meters long, okay? But that's one thing that you have to change, rather than
Yeah, you get one big problem, because normally you have to make these risk assessment for all parties who take part on these booths.
Yeah.
For example, it starts with the carpet guy who brings the carpet in, the next guy is the light guys, and every company has to do his own, or all in one. So at the end you get for these small booths, for every partner who work with, 5 or 6 partners, extra papers. Yeah, who will read, who will help, for who help anything. It's just for the
Okay,
paper
I don't
box.
have an answer for that, okay? Another question. That's it? There are no questions? Okay, good. More time for lunch.
Keine Frage mehr im Raum? Ja, dann von meiner Seite aus vielen, vielen Dank, Herr Rulling. Wir sind froh, dass Sie hier sind, dass Sie rüberfliegen konnten, uns einen Einblick geben konnten in dieses Thema.